This is the screencast for section 5.1, example 1. Alright, so example 1 says using identities. Find the sine of theta and cosine of theta if tangent of theta equals 5 and cosine of theta is greater than 0. Well, if we're supposed to find sine and cosine, and we know tangent, at first that seems really easy because isn't tangent just sine divided by cosine? So if tangent is 5, what divided by what is 5? Well, 10 divided by 2, 5 divided by 1, 20 divided by 4, 100 divided by 20. So you can't, there's too many options there. We have to find something that directly relates tangent to only one of those, sine or cosine. So if I go to my Pythagorean identities, I see tangent squared right here. So 1 plus tangent squared equals secant squared. And I know that secant is 1 divided by cosine. So this Pythagorean identity directly relates tangent and cosine. So I'll be able to plug in the value for tangent and solve for cosine. So I'm going to use 1 plus tangent squared theta equals secant squared theta. Now, the problem says the tangent of theta equals 5. So 1 plus, instead of tangent of theta squared, will be 5 squared. Equals secant squared theta. So now that will be 26. And if I take the square root of both sides, technically I get plus or minus the square root of 26 equals secant of theta. So if secant is 1 over cosine of theta, regular cosine is going to be 1 over plus or minus square root 26. Now, the original problem says cosine of theta is greater than 0, so we know that cosine is going to be positive, so this is just 1 over square root 26. If you want to rationalize the denominator, it would be square root 26 over 26. Now, since I know tangent and I know cosine, I can use the setup that we were originally talking about. Tangent of theta equals sine of theta divided by cosine theta. And I can say tangent is 5, sine is what I'm trying to find, and cosine is 1 over the square root of 26. So instead of sine divided by, I will multiply by 1 over square root 26. And then I get 5 divided by square root 26 equals the sine of theta. The now try problem is example 1. Same kind of setup. It says find the sine of theta and the cosine theta if tangent of theta equals 3/4. So I will use the Pythagorean identity 1 plus tangent squared theta equals secant squared theta. Tangent they gave me is 3/4. So this will be 1 plus 9/16. Let's see, 16/16 and 9/16 is 25/16, which will be secant squared. So if I take the square root of both sides, that will be 5/4 equals the secant of theta. Technically plus or minus. Now, the original problem only tells us that sine has to be greater than 0. Well, I know that tangent is sine divided by cosine. So if tangent is positive and sine is positive, cosine also has to be positive. Therefore, secant 1 over cosine has to be positive. So if the secant of theta is plus or minus 5/4, cosine of theta is going to be positive 4/5. Now I will use the other basic identity. Tangent of theta is sine over cosine. I know that tangent is 3/4. trying to find sine of theta. I know cosine is 4/5. So now it's sine of theta divided by 4/5, so I will multiply by 4/5. Both sides so that the 4/5 technically cancel. Then, let's see, these 4's cancel, so 3/5 equals the sine of theta.